Here we go. Should be like January 7th, 2022. So in order for you guys to be aware of how this is going to work, if you're here in class, you got nothing to worry about because you're going to get all this information because you'll be here live. But if for some reason you are not able to be here one day, I'm going to make this video and I am going to post it or upload it to YouTube. Once I get it on YouTube, I will create a Google Classroom. I don't know if I'll create it as probably as an assignment just because people look at those, but it'll be an assignment that just says class video for, and then I'll put the date. So for today, it'll say class video for 1/7/2022. And in the assignment, I will put the URL for the video that's on YouTube. So I'm not going to upload, I'm not going to insert the YouTube video into the assignment. The whole purpose of the Google Classroom assignment is just so that you can see the URL for where the video is on YouTube, and then you can just cut and paste into a new window and go there and then watch that video and get whatever, you know, information you can out of it. So like, for example, in yesterday's video, which I have not uploaded yet, towards the end of the lecture, there would be the reference to the worksheet and problems 1 through 6 with the idea that you were supposed to, at least by today, try 1 through 3. And if you wanted to, you could try 4. And today we're going to look at 5 and 6. And then the video ends. And that's where we leave off. And so today, what we're going to do is we'll take a look at 4, 5, and 6. And then, this video is going to end because I'm just going to give you time to work on those problems. So, somebody wasn't here yesterday. Alexis. Okay. So let me, see, I told you, I'm not stopping this thing. The people are going, where'd he go? He left. There's your worksheet. Everybody else was here yesterday? Okay. So what we are going to do now is we are going to take a look at numbers 4, 5, and 6 on the worksheet so we can kind of map out your approach to solving them, and then I'll just give you time to work on them. Okay? So starting on number 4. Oh, and for those people who are, I guess I'll hurry and put this up there. For those people who were not here to actually get the worksheet, remember you can go to, I'll put it up here. I think I'll put it, you can go to that particular website, and that's my physics homepage, and on the left side of the page you'll see a thing that says physics, and when you click on there, you'll want to go to physics, and then you'll want to go to worksheets, and then there are 2 separate worksheets listed on the web page that are all stapled together in your packet if you were here for, and one of them was called Momentum, and the other one was called, I think it's Momentum Extra. And so you can digitally access the packet that everybody who's been here in class has picked up by going online and going there. And if I get a chance, maybe I'll just upload them onto the Google Classroom assignment as well, so it'll be right there. But there's no excuse for someone to say, oh, I didn't know where they were. Okay? Okay, so let's get to number 4. Number 4 talks about a train, and it tells us it's over 7 kilometers long, and it traveled 535 miles in 22.7 hours, and it gives the train's average momentum, and we're supposed to figure out the mass. Okay, so my first question is, what is the main equation that we have to make use of in order to solve this? Michael.
Velocity.
Okay.
Or momentum.
I would say let's start with momentum.
Yeah.
And what's our equation for momentum?
P equals m times v.
We have P equals m times v. Okay? Now, we'll come back and identify a few things. But we are supposed to solve for the mass here. So we're good there. What of these other variables did they actually give us the number for? Stella? They gave us P. They gave us a flat out number for momentum. So that means all we need is the V. So the question is, did they directly give us the V? No. So what are we going to have to do to get the V? And I think this is where Michael was going. Ilya.
You're going to have to divide.
Well, that's when we're going to actually finish solving for this. But what equation do we have to make use of in order to figure out what the V is?
The velocity equation.
Which is what?
Delta x over t.
Delta x over t. So we have this V equals delta x over t. So right now, in a kind of graphic way, our problem is mapped out for us. We have to use some information to figure out what the velocity of the train was, so we can put a number here. They actually gave us the momentum, so we'll have a number here, and then we'll be able to use this equation to solve for m. So now, going through the problem, somebody identify a variable for me that was given. And I'll write it up here. Okay, Alexis?
T.
Okay, what was our P?
7.328 kilograms times meters.
So kilogram meters per second. Okay, so we're good there. What other piece of information have they given us?
Time.
Okay, they gave us a T. What was the T they gave us?
22.7 hours.
22.7 hours. Okay, now this is where I'm going to say, I could wait till later, but is there something you want to tell me about this one? Julian? We need to get it converted to seconds because, remember, our momentum is measured in seconds. So maybe we'll keep things entertaining and change colors for this. So I'm going to do this, convert to seconds. And that's where I will leave that up to you. Okay? What else? Okay, Michael?
The train traveled 535 miles.
Which would be what variable up?
Delta x.
That is our delta x. So that was 535 miles, and
You want to convert that to meters.
we want this convert to meters. So once you have that taken care of, when we look at what I've put together up here, we have a delta x and we have a t. So that is going to allow us to calculate what this v is that we can then move here. So we can do that off on the side. And they gave us the p, so we are all good to go now. So you're going to have to do this in a couple steps, but that's how we can go ahead and solve number 4. Now let's see, let's double check our time, 26. Okay, now I have a question for you. You want me to give you 5 minutes to actually do this, or erase this and go to number 5? Who's looking at this going, oh God, I want to hurry and get it out of the way? Come on. Okay, because if we're gonna work on it for a few minutes, sorry people, we're turning you off. We'll stop the video and then we'll pick back up to do number 5. Fair enough? Okay, so I'm gonna give you 5-6 minutes. All right, now I'm gonna have to go learn how to splice these two things together. Yeah, I know it's on there. I've never used it, so this will be a fun little project for me. Okay, number 5. So for number 5, it says they have a tower that is 22.13 meters tall, and it's built of Legos. And it says, let's suppose one of the little Lego blocks that has a mass of 2 grams is dropped from the top of the tower, and we're going to ignore air resistance, and we're supposed to calculate the Lego piece's momentum at the instant the piece hits the ground. So, quick little, I'm not going to show all the little Lego things. Here's our little tower, and then here's our little Lego piece, and it says this is just going to fall down to the ground, and so we want to know how much momentum does it have right when it gets to the ground. What's our only equation for momentum?
P equals M times V.
P equals M times V. And I'm going to come back to this, but what thing did they give us in this equation? Directly.
Mass.
They gave us the mass because they said this little piece is 2 grams. And there's stuff we'll have to do with it, but if we identify that that's mass, that means we have the M. So if we are supposed to calculate the momentum, the thing that we're missing is
Velocity.
the velocity. So what we need to figure out is what's the velocity of this piece right when it gets to the ground. Now, as a review question, what kind of problem is this that we've dealt with before? What did we call it?
Free falling.
Free fall. And what was special about free fall? What value did we get to use? What?
Negative.
Negative what?
9.8.
9.8 meters per second squared. So what we have here is a free fall problem. So if we look at the free fall nature of what's going on here, remember this is where we had those 4 different equations. What pieces of information do we have about the falling object? You mentioned one already, which was what variable when you said the negative 9.8? Acceleration. So acceleration equals negative 9.8 meters per second squared. What else do we know?
Because it was dropped from the top, the initial velocity is 0.
Correct. It said it was dropped, and that means our VI equals 0 meters per second. And we know one more thing. What?
The mass.
Well, we know the mass, but I'm going to put that over here because that's not part of the free fall part. What was the actual value of the mass?
2.8.
What?
2.8
What's the unit?
grams.
Grams. Okay, what's the other thing? Alexis. Okay, which is, how did they give it to us in the problem? They said this thing was 22.13 meters. It's a pretty damn tall Lego tower. Okay, what variable is that going to be? Delta X. Now I'm going to be really picky here. If I just put 22.13 meters, what's not 100% correct about that?
Would it be negative?
Why?
Because since it's a free fall, the top top is the positive and the bottom is
Right.
the negative.
In a free fall problem, we take up to be positive, down to be negative. Okay? Now, what thing do we need to find from this information so that we can go over and start to make use of that?
The final velocity.
Correct. So we want to find VF. Now, this is where I will tell you, if this was like a test question, because once we put this all together, I'm not going to look at this like, oh my God, this is so over the top hard. Once we put this together and you go, oh, that's acceleration. I know how to do that. Oh, I've forgotten the equations. All your acceleration equations would be up on the board. So you wouldn't have to have those memorized. But for those people who remember them or maybe are looking at them, which equation would we use to solve?
Equation 4.
We would use equation 4, which is 2a delta x equals vf squared minus vi squared. So we're going to use this equation and solve for VF. And once we solve for this VF, where is that going to go?
Into the first equation.
Into this one here, right there. And they gave us the mass. What detail do we have to take care of here?
Kilogram.
Okay, you guys are getting this. This convert to kilograms. And then this value goes where the M is. Now I'm gonna point out one more thing, and then I'll give you the rest of the period here to chew on this one. There is something very, very picky about that you need to remember about solving for this VF. What's the last math step that you're going to take to solve for VF here? Okay, what do they call it?
You have to square root both
You're
sides.
gonna have to square root. Now, when you square root, and usually you don't have to worry about this, but in this case you are. If I ask you in math, what is the square root of 9? What is technically the correct answer?
Positive or negative 3?
Positive or negative 3. Which way is our Lego piece headed?
Down.
Downward. So which value do we take?
Negative.
The negative value. Will your calculator give you that?
No.
No. And this is where I tell people, your calculator is a brilliant calculating machine, but it doesn't think. So when you hit square root, if you had a really interactive calculator, one of the questions that it would ask you is, would you like the positive or negative square root for this? You would still have to determine which one you needed, but it doesn't do that. So by default, the programmers of calculators just said, look, usually people just want the positive value, so we're just going to have the calculator spit back the positive value. But that doesn't mean technically you always use the positive value. So I'm going to make a little note here. VF is negative. So when you do the square root and you get your value and you bring it over to your momentum equation to do that momentum calculation, remember to use the negative of that value. Okay. Does anybody have any questions on this one? Kind of see how all the pieces fit together? All right. I will say, as far as like a unit test question goes, something like this is fair game. But remember, this thing here would be up on the board. So you wouldn't have to have that committed to memory. I would have all the acceleration questions up there. But you would have to recognize, oh, I got to do some acceleration calculating here before I go over and do my momentum P equals M times V. Fair enough? Okay, so we're going to stop there for today. And I will say, you could take a stab at number 6. In doing number 6, you are not going to have to use any acceleration or velocity equation. You're just going to have to use your momentum equation twice. Because the idea is somebody's throwing a baseball but they claim that they can throw it with the equal amount of momentum that a bullet has. So you need to remember that technically the two different objects both will use P equals M times V, but they're supposed to have the same P value connecting them. So I'll kind of leave that one as an extra. I don't know if I'll come back and do that officially next time, but that's another good test question, because it's not just use this and you're done with it. You have to use this twice, but once is using it as it applies to the bullet, and the other one is as it applies to the baseball. But they share the same P value when you go to solve that one. So I will leave you with that and stop the video.